Okay, so the next question that we have is question number 10, which is the cosecant inverse of negative square root of 2. Negative square root of 2. So if I let basically the cosecant inverse of negative square root of 2 equal to y, for example, that means that y is equal to, that means that basically that means that the cosecant of y is equal to negative square root of 2. Now if we take a look at the table, the cosecant function here, you see that for the cosecant of 45 degrees, or pi by 4 is equal to square root of 2. The cosecant of pi by 4 is equal to square root of 2. So that is the same thing as the cosecant of negative cosecant of pi by 4. We also know that the cosecant of negative x is equal to negative cosecant of x. And so that means that this is equal to the cosecant of negative pi by 4, right? Now, we know that the cosecant function, as far as the range and the domain are concerned, you have the cosecant inverse function is a function that goes from r minus the open interval of negative 1 comma 1 to the range negative pi by 2 to pi by 2, and minus the set containing the element 0. So pi by 4, of course, negative pi by 4, of course, is in this range, which means that you can use it in this range. And so I know that basically the cosecant of y is equal to the cosecant of negative pi by 4, which means that basically y is equal to negative pi by 4, and therefore the principal value of cosecant inverse of negative square root of 2 is equal to negative pi by 4. Okay, that was question number 10. Question number 11, find the values of the following. So for example, question number 11 is tan inverse of 1 plus cos inverse of you have tan inverse of 1 plus cos inverse of negative 1/2 plus sine inverse of negative 1/2, right? But let's calculate them one by one. These are 3 angles, and then we need to add the angles together. So tan inverse of, and of course we are assuming here that we are calculating the principal values of these, otherwise, because no other assumption can we make unless stated otherwise, right? So the tan inverse of 1 is equal, if I take that as y, then that means that tan of y is equal to 1. So tan of y is equal to 1. That means that if you take a look at the table of values that we have, tan of 45 degrees is equal to 1. Tan of pi by 4 is equal to 1. And the range of the tan inverse function is negative pi by 2 to pi by 2. Is negative pi by 2 to pi by 2. So the tan inverse function is a function that goes from r to negative pi by 2 to negative pi by 2 comma pi by 2, the open interval. And so what that means is that this is the same thing as tan of pi by 4, and then the range here goes from negative pi by 2 to pi by 2, so that means that you can actually accept pi by 4. That means that y is equal to pi by 4, which means that the tan inverse of 1 is equal to pi by 4, right? So that is the first part of this question. The second part of this question is the cos inverse of negative 1/2. The cos inverse of negative 1/2, if I set that equal to y, that implies that the cos of y is equal to negative 1/2. Now the angle that for which the cos becomes, well, not negative 1/2 but 1/2 is equal to, so you know that basically sine 30 degrees is equal to sine 60 degrees is equal to square root of 3 by 2, cos 60 degrees is equal to 1 by 2. So you have cos 60 degrees is equal to 1 by 2, right? So that is equal to the negative of cos of 60 degrees, which is equal to pi by 3, right? Now I need to find I need to find some angle for which the cos is negative cos of pi by 3. So that means that if I have a unit circle over here, and so if I have basically the cos of pi by, so pi by 3 is basically this angle, it's a 60 degree angle. So basically you have 15, 30, 45 and 60. This is basically pi by 3. This is pi by 3. Now the cos of this angle is of course a positive value, as you can see. This is the cos of, this value is the cos of pi by 3. Now if I draw this angle over here, so if I draw an angle basically 15, 30, 45 and 60, you can see that this angle, whatever that is, this angle over here, will have the exact cos value. So, but I'm looking for a cos value which is negative of this cos value. So then I'm going to basically try this angle here. So basically I have 15, 30, 45 and 60. And I could also draw this angle, right? And so you can see that the cos of this angle and the cos of this angle are exactly the same values. So this is basically negative cos of pi by 3. Because as you can see, this distance is actually equal to this distance. So if this distance is denoted as cos of pi by 3, this distance is going to be negative cos of pi by 3, right? So now about the cos function, I know that the cos function is a the cos inverse function, the domain is negative 1, 1, the closed interval negative 1, 1, and that goes to 0, pi. The closed interval 0, pi. That means that I can go all the way from 0 to pi here, and so this angle is not is not useful, but this angle I can take it. Meaning that this angle is nothing but a 120 degree angle, because you have 90 plus, and this angle is actually 60 degrees. So this angle would be a 30 degree angle, and this is a 90 degree angle. 90 plus 30 becomes 120 degrees. 120 degrees is the same thing as, well, 2 times 60. 2 times 60 would be 2 times pi by 3, which is 2 pi by 3. That's 2 pi by 3 radians. Which means that basically that I can write as the cos of 2 pi by 3, right? And that is actually in the range of this function as well. 2 pi by 3 is actually in the range of this function as well. So I can say that y is equal to 2 pi by 3. Which means that basically the cos inverse of negative 1/2, the cos inverse of negative 1/2 is actually equal to 2 pi by 3. 2 pi by 3, right? So that is another part of this problem that we can use later as well. So this is one part, and that is another part. Now we have also sine inverse of negative 1/2. We have also sine inverse of, so if I said let's sine inverse of negative 1/2 be equal to y, that implies that sine of y is equal to negative 1/2. Now I know that the sine of 30 degrees, which is equal to pi by 6, actually sine of pi by 6 is equal to 1/2, right? And I know that so this is the same thing as negative sine of 1/2. Negative sine of pi by 6. Negative sine of pi by 6. Now, I know that the sine of negative x is equal to negative sine x, right? So, which means that this is the same thing as basically sine of negative pi by 6. Negative pi by 6. Now, the domain and range of the sine inverse function, the sine inverse function is a function that goes from negative 1, 1. It goes to, actually, the closed interval it has to be, and it's negative pi by 2 to pi by 2, and that is basically, and so that means that negative pi by 6 is actually in the range of this function. So I can conclude that y is equal to negative pi by 6, because sine of y is equal to sine of negative pi by 6, which means that basically the sine inverse of negative 1/2 is actually equal to negative pi by 6. Negative pi by 6. So now that is another part of this question. Now the question was originally tan inverse of 1 plus cos inverse of negative 1/2 plus sine inverse of negative 1/2, that is equal to, so tan inverse of 1, we said that it's equal to pi by 4 here. It is equal to pi by 4. Cos inverse of negative 1/2 is equal to 2 pi by 3. And sine inverse of negative 1/2 is equal to negative pi by 6. So that is equal to, take the 3 and 2, 24. So I take the LCM as 24. 24 divided by 4 is equal to 6, that's at 6 pi. 24 divided by 3 is equal to 8, 8 16 pi. And 24 4 negative 4 pi. And that is equal to 6 plus 16 is equal to 22. 22 minus 4 is equal to 18. So that's 18 pi by 24. Now divide by 6, you'll get 3. Divide by 6, you get 4. That's 3 pi by 4. So question number 11. Question number 11 is equal to 3 pi by 4. Okay. That is that the answer is correct. Now, the next question that we have is question number 12. Okay, so the next question is question number 12, which is basically the cos inverse of 1/2 plus 2 times sine inverse of 1/2, right? So the cos inverse of 1/2 would be cos inverse of 1/2. If I set this equal to y, that means that then that means that the cos of y is equal to 1/2. So what is some angle whose cos is 1/2? That is basically the angle would be basically, if you go for basically 60 degrees, or basically pi by 3, right? So the sine of 60 degrees is equal to square root of 3 by 2. The cos of 60 degrees is equal to 1 by 2. That is equal to 1 by 2. So that is equal to the cos of pi by 3, which is basically 60 degrees, right? Now the cos function basically is basically a function. The cos inverse function. The cos inverse function is a function that goes from -1, 1, and that goes to 0 to pi. It goes to 0 to pi, which means that pi by 3 is actually in the range of this function. So I can say that y is equal to basically pi by 3, which means that basically the cos inverse of 1/2 is actually equal to pi by 3, right? Now to calculate the cos inverse of the sine inverse of 1 by 2, you need to basically calculate, basically you know that sine 30 degrees is equal to 1 by 2, which is equal to the sine of basically 30 degrees is equal to pi by 6. So sine of pi by 6 is equal to 1/2. So sine that so let's say that, for example, let sine inverse of 1/2 is equal to y, which means that the sine of y is equal to 1/2. If sine of y is equal to 1/2, that is equal to sine of pi by 6, and the sine inverse function is a function that goes from -1, 1, and that goes to negative pi by 2 to pi by 2, and pi by 2, And so basically pi by 6 is actually in the range of this function. So I can say that basically y is equal to pi by 6. I can say that y is equal to pi by 6, or I can say that basically the sine inverse of 1/2 is equal to pi by 6. Now what we wanted to calculate here was basically cos inverse of 1/2 plus 2 times sine inverse of 1/2, which is equal to, now cos inverse of 1/2 is equal to pi by 3. 2 times sine inverse of 1/2 is equal to pi by 6, which is equal to pi by 3. Now this is divided by 2, 1 divided by 2, 3. 6 divided by 2 is equal to 3, so that's pi by 3 again, so that's 2 pi by 3. That is 2 pi by 3. That is the correct answer. Okay. Now the question number 13. Question number 13, we have if sine inverse of x is equal to y, then this is question number 13. If sine inverse of x is equal to y, then a, you have 0 is less than or equal to y less than or equal to pi. B, you have negative pi by 2 is less than or equal to y is less than or equal to pi by 2. C, you have 0 is less than y is less than pi. And D, you have negative pi by 2 is less than y is less than pi by 2. Right? So if sine inverse of basically x is equal to y, so what that means is that but this x is some ratio and this is some angle, and we know that basically from the range of this function, so we know that the sine inverse function is a function that goes from negative 1, 1, and that goes to negative pi by 2, pi by 2. Right? So if I take this function, and so basically that means that y belongs to this set. So if I say that the sine inverse of x is equal to y, that means that y belongs to this set here, which is y belongs to the interval negative pi by 2, pi by 2. If y belongs to this set, then of course you can say that negative pi by 2 is less than or equal to y is less than or equal to pi by 2, right? So which is basically choice D. Right? Oh, I actually did this wrong. I wrote the right answer, the correct answer here, but I made a mistake here, so it's actually choice B. Negative pi by 2 is less than or equal to pi, less than or equal to pi by 2. That is question number 13. Now question number 14. Question number 14 is basically tan inverse of square root of 3 minus secant inverse of negative 2 is equal to a high, b negative pi by 3, c pi by 3, and d 2 pi by 3. So tan inverse of square root of 3 minus secant inverse of negative 2 is equal to which of these? So we can begin with tan inverse of square root of 3. Tan inverse of square root of 3. If I let this be equal to y, that means that tan of y is equal to square root of 3. Now, I think that is, if I'm not mistaken, tan of pi by 3 is equal to square root of 3, tan of 60 degrees. So tan of, so this is equal to tan of pi by 3, right? Now, the tan inverse function basically is a function that goes from, r to negative pi by 2 comma pi by 2, the opening rod, and pi by 3 is in this range, and therefore you can say that basically y is equal to pi by 3, or you can say that basically tan inverse of square root of 3 is equal to pi by 3. That's what we were looking for. The second part of this question, you want to calculate secant inverse of negative 2. Okay, so now I did a couple of things, but then I got kind of entangled in my own logic, so I have to start over. So what you want to do is that you want to calculate basically the secant inverse of negative 2, right? So if I say that let secant inverse of negative 2 is equal to y, right? That means that basically then secant of y is equal to negative 2. Secant of y is equal to negative 2. Now, the secant of, basically we know that the secant of pi by 3 is equal to 2. We know that the secant of pi by 3 is equal to 2. So I can write this as the negative of secant of basically pi by 3, right? Negative of the secant of pi by 3. And I know that now this part is a little bit tricky because secant of negative x is actually equal to secant x. It's not like other trigonometric ratios. The secant of negative x is equal to secant x, which means that we have to use the unit circle in order to figure this out, basically what sort of angle we can use, so that we can express this in terms of the secant of some angle, basically. So if I draw a unit circle over here, and border I think Okay, so now if I basically the angle that I have is secant of pi by 3. Now secant, you cannot, well, pi by 3 is basically this angle over here. So this is 0, 15, 30, 45, and 60, which is basically the angle pi by 3. Pi by 3 is equal to 60 degrees. This angle is over here is pi by 3. Now I cannot show the secant, basically the secant trigonometric ratio directly on the circle. I can show the cos and the sine functions over here, and I know that the cos of this function is equal to this value over here. I know that the cos of basically pi by 3 is equal to basically cos of pi by 3 is equal to 1/2, right? And I know that the secant of pi by 3 is equal to 1 over cos of pi by 3, right? And that is equal to 1 over 1/2, which is equal to 2, right? Now I need to be looking for some angle whose cos is not 1/2 but negative 1/2, so that when I take the reciprocal of that, which becomes the secant of that angle, that gives me negative 2 instead of 2. So which means that I can and that angle has to be also in the range of the secant inverse function, right? The range of the secant inverse function goes from 0 to pi, excluding pi by 2. At pi by 2, secant is not defined, of course. So if I draw this some angle over here, which is basically 15, 30, 45, and 60, and as you can see, this angle, this distance over here, these two distances are exactly the same, except that this distance is positive, this distance is negative. And this angle over here is basically 90 plus pi by 6, or I'm sorry, pi by 2 plus pi by 6, which is equal to basically 6, 3 pi, and plus pi, which is equal to 4 pi by 6, which is equal to 2 pi by 3. 2 pi by 3. So this angle over here is 2 pi by 3. Now we know that the cos of basically 2 pi by 3 is equal to negative 1/2, is equal to negative of the cos of pi by 3, which is equal to negative 1/2, which means that the secant of basically 2 pi by 3 is equal to basically 1 over cos of 2 pi by 3, which is equal to 1 over basically negative 1/2, which is equal to negative 2. Right, so that's the angle that you're looking for, which means that over here what I have written is basically the secant of y is equal to negative 2. That is equal to the negative of secant of pi by 3, which is the same thing as the secant of 2 pi by 3. Right? And secant of 2 pi by 3 is actually in the, the angle 2 pi by 3 is actually in the range of the secant inverse function, because the secant inverse function is a function, secant inverse function is a function from r minus basically the open interval of negative 1 comma 1, and that goes to 0 to pi minus the set containing pi by 2, right? So and this angle is actually in the range of this function. So I can basically, so secant of y is equal to secant of 2 pi by 3, therefore y is equal to 2 pi by 3, right? And therefore the secant inverse of negative 2 is equal to 2 pi by 3. Is equal to 2 pi by 3. Now what we were trying to calculate was this basically expression over here, which was basically tan inverse of square root of 3 minus secant inverse of negative 2. Now this is equal to tan inverse of basically square root of 3 is equal to pi by 3, and secant inverse of negative 2 is equal to 2 pi by 3. 2 pi by 3. Now negative 2 pi plus pi is equal to negative pi thirds. And that is basically the answer that we were looking for. Negative pi thirds is this choice over here, choice B. So choice B is the correct answer. Yes. Okay, so that was basically exercise 2.1. In the next video, we will talk about properties of inverse trigonometric functions. I'll see you in the next video, and thank you.